Hello everyone. We're going to be looking at maps and storytelling today. Normally would save this to the end, but because what you guys do for as a career or at least as a degree, it's so important to talk about storytelling. I wanted to put extra emphasis on this. Normally this is like a half a lecture each one. I just blaze through a bunch of slides, put them together, but I wanted to take my sweet time on some of these ideas and topics. So let's go over some of the things. So I don't know if I actually did I remove the announcements? User evaluations, we already talked about this, but let's just review the user evaluations. I'm going to pass off a set of instructions soon, whenever I get around to it, for how we want to do the user evaluations. That should be next week during the lab time. Now, it's actually not going to be happening during the lab time, but it would be due for that period of time, what you would have for your instructions for the people that are evaluating your system. And then the following week, I would expect to have you guys pass in videos or links to videos so that we can share amongst everybody so that we can all watch the videos and give feedback or ask open questions on Piazza. So last time around, when we last left our heroes, we were looking at node link diagrams. And this is things like this is a normal node link diagram where I have edges and nodes, and for each of the nodes and for each of the edges I can color with different colors. I'm going to do full screen as well. I could color with different colors. I can change the size of things. I can do normal Gestalt principles. So I put things together and I get automatic groupings. Proximity to each other also tells me how things are related. If they're connected, tells me that's what the edge is for. It tells me that the two things are connected. My nodes themselves can differ in terms of color, in terms of hue, in terms of saturation, in terms of lightness. We can talk about different sizes of nodes. We do different shapes of nodes. And the edges themselves can be different colors, different thicknesses, different styles of the edge itself, different directionality, or how I do the particular arrows. They're all very open. It's very well explored space, and it's just something that you want to think long and hard about every single time you make a node link diagram. What ideally are you trying to get across? Are you just trying to put nodes on the screen? Probably not. What is the main piece of information you're trying to get across for people, and therefore designing the visualization accordingly. All right. So, and we looked at some of these more insane ways of doing visualizations, and this, as I said, is a pretty. I think it's a great video at least for how you can brush a particular area or select a particular region and see the connections between two different regions just by having a slew of different nodes in that region. And then you can have individual visualizations per that region and then see what the path is to other regions. And we looked at adjacency matrices as well. And we'll actually, I think we see an adjacency matrix later on when we look at storytelling. Now I'm going to break this into two parts, despite the fact the slides say storytelling in maps. I'm going to do maps first, take a break, and then we'll do storytelling. Hopefully I'll do both today, and then after that record both today, and then after we do all of this, then we'll go to I think three-dimensional or scientific visualizations, so things that are spatial in nature, and I might do some dimensionality reduction, but probably not. And then I'll have a presentation on how to give a presentation, and then that would be it for the slides. So four more sets of lectures, but 3 more days. And so again, here's our adjacency matrix, just because I'm pointing out what we're going to when we're talking about communicable diseases later on. This comes up, and what we can do with mixing adjacency matrices and node link diagrams. So let's talk about maps, because almost everyone's projects involved some form of map. Why? Why was everyone so insistent on using maps? And I'm sure you can give me a quick answer or have that answer in your head. Maybe don't say it out loud. Your roommate or people nearby might think you're weird. Why were we using maps? There's a reason. Well, it's not as intuitive as it sounds. It's not as boring as it sounds. Maps give you something that you couldn't get otherwise. They're really intuitive in terms of how you go about thinking about a problem. Uh, yeah. So what are we looking at? We're looking at how we visually encode maps themselves and the different pros and cons of each of these approaches. And so we're looking at map types, how we can encode information on maps, that sort of thing. And what are the concerns that we have to have? So last time we were looking at, when we talk about, we're talking clearly in spatial. Now, when we say spatial, it could be almost any spatial information. It does not have to necessarily be a map, but maps are the classic one of this. So spatial information, it could be, a room. That could be, there's a geometry to it, but yeah, really we're talking maps most of the time. So it has a given geometry. It's geographic, and we can also have other derived, and we can put other derived information on top of it. So I can put dots on it, I can put arrows on it, I can overlay information on top of this map. And the person looking at the map though already knows what the shape and the look of something is. Everyone when they see this image knows what it's a picture of, or at least I'm assuming you know what it's a picture of. Not and it's not necessarily despite the coronavirus. That this slide is a lot older. This is not for anything involving outbreaks, but we'll see those very soon. In case you were wondering, the map gives you something that it gives you the context, the thing that we're always striving for. When we're talking about our abstract data, we are always looking like focus plus context. We're looking at how we get the context surrounding how our visualization works. And this comes for free. A map is, you know what this thing looks like. And if you don't, well, maybe that's part of the point of the map, but most of our examples are, the most examples you gave me were you're using a map to give you the context, to tell you, to situate the data. By the way, they're pretty much one of the oldest visualizations that we actually have. And you might say, what the heck does a water buffalo, bison, whatever the heck this thing is, what the heck does that have to do with a map, right? It's a cave drawing. So what, it's clearly not showing directions to the nearest hut. So what the heck is it? Well, so this is 16,000 years old. It's a cave, and yeah, it's a star map actually. When they actually when they looked at it afterwards, they found out the actual, or it's a weird coincidence, but the actual shapes of the animals are actually encoding information about the stars themselves, which I find fascinating. Clay tablets from Babylon, from 1400 BC. How do you get to Bob's house? The clay tablet tells you the way, right? This is, everyone does this sort of naturally. It's not something we've refined maps over the years, but maps as a concept are fairly, not rudimentary, but it's a natural thing for us to want to use, despite the fact there's a transformation from three-dimensional space to two-dimensional space, this projection, and yet people still can do it and still actually make these things. So let's have a look at what we're using in a map. So we had marks, which are points, lines, and areas, let's say, plus others, but we also have different channels. So we have position, we have color, we have shape, we have tilt. Let's see what the heck a map gives us. So here's a simple map. We could add a lot more stuff than this. Well, first of all, we have position. That is the big takeaway for any map. That X and Y position is the geographic information 99.999% of the time. Actually, I don't think it's a map unless it encodes it with position in X and Y. Okay, what else? Well, the color of the pixel itself is actually indicating what it is. It's either land or water in this case. It could be different countries. It tells you, the color itself can encode one other piece of information. We also have mountain glyphs in this particular example. We also have water glyphs as part of water, I suppose, but we could put other kinds of glyphs on top of this thing. Oh wait, we also have country boundaries, which is a line itself, right? It depends on what you're trying to encode, but within this very simple map, not showing anything, not even having text on this thing, and text could also encode more information. I have shown encoding 5 different attributes. I'm using all 3 kinds of marks that I have, and I'm using X and Y position, I'm using color, I'm using shape, and I think I'm using one area for the country itself. Right? It's fairly dense, and it's incredibly intuitive. That's why we love maps. So, how do we look at this? Well, first of all, I wanted to do a quick overview breakdown of everything. So, when we're talking about maps, how do I encode information on it? Well, first of all, I can actually overlay stuff on top of it. Dots and glyphs, for example. I can also do overlay of areas, or do things like lenses, right? So I put the bus maps on top of the map. I can put a heat area, so the number of accidents based off of, color intensity on top of the map. That's not the map itself being changed. I'm just overlaying a color on top of it, and that has a particular shape, but it's a semi-transparent layer on top. I could color the individual regions. This is where when we were talking chloropleth maps before, that where you color in that particular country based off of how many, what the mortality rate is, or I color in the area of the city based on the number of traffic accidents, or I color in the area of the city based on the crime rate. That would be a chloropleth map for most people. And although I've never seen this, or I've rarely seen this, you technically could use the outline of the map to encode information if you really wanted to. I can't even think of an example of someone doing it, but that was something that sprung to mind. But I could put stuff on top of the map, I can change the underlying things, or I can do the outline. The color regions, the reason I say the word granularity is that is the big takeaway. That's why chloropleth maps, one of the problems with that they have, they're intuitive, but a chloropleth map distorts the data because Texas is a huge region, or Montana is a huge region. Great Northwest Territories, huge region, and yet there's not many people. So if you're talking about how many votes they have, or where the seats in parliament, where your MPs are. The if you look at a map every single election time, it looks like the Liberals are completely crushing it because the Northwest Territory tends to vote Liberal. So does, I think, Yukon and a couple other, most of the territories vote Liberal in general. Newfoundland tends to vote Liberal. Toronto is all over the place, and yet it's this incredibly small geographic area with a whole lot of seats, right? Chloropleth maps hide all of that because big red regions suggest a lot of things. Now, if I change the granularity and say what it doesn't work for MPs, for example, but if I'm talking the number of car accidents per thousand people, and I put that on a map, I could do that same map, but if I make these little minuscule regions, what I get is Texas doesn't suddenly come up one color, it comes up this multitude of different colors. If I increase the granularity, I might be able to see into smaller regions. I might be able to see more information, or it gives me different information. And so that's something to consider. So I like talking about. So this is all well and good, especially when it comes to like a street map, a map of a city. These all work are well and good. And you worry about chloropleth maps. Maps of the world are an interesting little thing that I like to point out. So it turns out a map itself, it's a dimensionality reduction. The world is, in fact, I know, crazy, it's not flat. I'm going to state that for the record. I'm going on a limb here. I'm saying the Earth is not flat. I know some of you may disagree. Anyways, but if I have a sphere, how the heck do I represent it in two-dimensional space? This is a dimensionality reduction technique. We can actually look at this in a bunch of other domains as well. Our technically, our node link diagram was a dimensionality reduction, but if I'm trying to map music onto a two-dimensional space, it's dimensionality reduction. If I'm taking the 3D world and trying to project it to two-dimensional space, no matter what I do, I'm going to distort the data. There's no way around it. It's three-dimensional data that I'm converting into two-dimensional data. So here's the globe, and when I project it, I get maybe something like this. Now, no matter what I do, I cannot represent a two-dimensional space, a three-dimensional space in 2D, even if it's just the shell, outside shell of it. I will distort things. And so we have a number of different problems that pop up there. So there are some great videos about this. So why all world maps are wrong. That's, it's a fascinating view about history. I highly recommend it as a video. It's probably better than any amount of lecturing I'm going to do. So take a pause if you want right now. Have a look at it. I think it's fantastic. That's just one. It's a nice summary of all the things we're going to be talking about later, yet said in a very intelligent, very nice, clean, well edited kind of way. So I'll let you pause. Okay, now if you hadn't already paused, or if you did pause, great, welcome back. Um, what's interesting about this is because it's two-dimensional, because you have to either have to stretch things or you have to get wrong and you have to fill in things. No matter what, you have this distortion. And I always think of the orange peel. So when I first started looking at maps as a kid, you'd see a two-dimensional map of the world, and then they started using that sliced version of map of the world, and I'll show you an example of it. That's what you'd see when you see a command and control center. And I used to ask my dad, like, what were I asked him once at least, why do that? And then you break out an if you break out an orange, you'll see this. And there's a Hannah Fry lecture also discussing that exact projection issue, that no matter what, just squishing it down means you're going to break something. It's going to stretch or mold something in some other way. So here are different techniques. I can either just take a surface, a flat surface, a slice, and or projection onto a plane. So this would be, I take a planar surface. If I took all the points on the world and just shot a ray straight up. So I have rays coming from the Earth hitting that plate straight up. I will get a particular image. I will get a flattened circular map like this. If I do the same projection with a cone, I get this. If I put a cylinder around the world, so imagine I wrap it up in a cardboard cylinder, right? And then I do a projection of I cast a ray from the Earth to the wall of the cylinder. I get the Mercator map. I get this rectangular map, which keeps all the right angles for everything. So cylinder projection, azimuthal, and then conic in terms of, and these are great views. You can look at all the various. It's kind of incredible. So here we go. Various cylindrical maps, cylindrical projections over time. I can do this. I can pseudo-cylindrical. I can do all sorts of fun stuff. Conic. Here's a conic map of the world. Okay, so depending on how you want to view this thing and where you want to put the plane, you'll get different results. All right. There's a butterfly map. Great. And where's my personal favorite? I don't think they even have the full orange peel map that I love. They do not have my orange peel map. Darn it, or at least I can't see it. Oh, there it is. This one, Bogs. The Bogs map is the one I sort of grew up with and seeing. Or Good Homicide. Those kinds of maps are normally when you see in a command and control center, right? It's imagine peeling an orange and then just flattening it out. So let's go back to this. Here's there you go. Goods it's trying not to distort the world, but you're still getting a good worldview and correct sort of proportions, correct dimensions of all the different countries in the world. Because what you're really worried about, you're not worried about that big piece of water in between. You're worried about, the USA and the USSR during the Cold War, and so you actually want to not distort those, but still and see everything right. Here's Mercator. Mercator is sort of the standard. It was the classic for a lot of this. I like the Miller. Gull Peters is, I think, what the UN is currently using right now. But notice how it doesn't distort the size of the various countries. So that's actually correct, unlike Mercator, which horrendously distorts the country sizes. But look at it, it just squishes on the top. You get this massive distortion on the poles. So we can look at all these things. And if you really want to nerd out on this sort of thing, this is the first of Hannah Fry's videos that I have. And I don't know why I have two Hannah Fry things for this series of lectures, but I do. Great discussion on how you can do a world map with minimizing the distortion of the actual geographic areas by putting on two-dimensional space. Unfortunately, it means it's completely unreadable in terms of countries. Everything goes out of alignment because what they're using is an Euler spiral, I do believe it's what it's called. It's essentially you peel around very, very fine strips of the entire world all the way around, and then you lay it out flat using a bunch of cylinders on both two different cylinders, and then connected through a middle point. I like to think of the fact that she's a British person discussing map problems, despite the fact that British people gave us most of those map problems, including let's make some random territories in the Middle East, or hey, let's use the Mercator map. Uh, they ran the world. There's a reason that's they anyone running the world would cause those problems, but they were running the world when these things came out. All right. So this is an interesting view if you want to look at it from a mathematics standpoint, why maps work or not. Fascinating. I find her very entertaining. So, um, and in case you were wondering, yeah, I don't know about the Ontario schools, but the Boston Public Schools do not use a Mercator map anymore, just because it's horrendously distorts things. So here's our Mercator map projection. Yeah. Here's Gauss-Peters. Better. Now, Africa is the right size, but notice, you know, the Northwest Territories and Greenland look horrendous. Now, they are the right size, but they're smeared. They're distorted horizontally and vertically. They get squished down vertically and they get smeared out horizontally, right? And so both the first video I pointed out, which I asked you to watch, I love the fact that the point is, it's never right. You cannot make it right. So the question is, what are you trying to get with? What are you trying to accomplish with your map? Okay, choose the map that helps mitigate those costs and maximizes the benefits. If you need to have right angles because you need to see where you're navigating. So, for example, Mercator, great for ocean navigation. If I need to get from, Newfoundland to England, I want a Mercator map, right? Before GPS, Mercator map is my friend, right? Because I need to know the direction, not to have any kind of curved distortion. I don't want to be going northeast when I should be just going straight east. But it drastically exaggerates the poles. But that's okay. If I'm just trying to get from point A to point B, I don't care how big Greenland looks. If I own land in Greenland, yeah, I care. But if I'm just trying to sail to Greenland, I just want the Mercator. Uh, and the Gauss-Peters projection, it's officially endorsed by the UN, but like that stretching is ridiculous on the top. And so if I'm traveling from one place to another, I'm going to be going in the wrong direction. With a GPS, it's not a big deal. And at least it doesn't lead to the idea that, Africa's this tiny little continent. Oh yeah, it's like Europe, right? It's huge. I mean, look at this thing. Yet in the Mercator, Greenland looks the same size. In fact, here's Australia. Here's most of Europe fitting into it. Here's Japan easily fitting into it. Here is the United Kingdom ridiculously easily fitting into it. Here is the United States almost fitting into it. Like, it's a big country. The United States is way bigger than we give it credit for because the Mercator map seems to suggest that Canada's way bigger than the US. It's not that much bigger than the US. It is, but yeah, and we won't let them live it down. But it is not so much more ridiculously bigger than the US compared to what we think it is. So, here's the true size of Africa. You can fit the entire United States in the upper left-hand side. Like, yeah, the Horn of Africa holds India. Like, that is insane. Eastern Europe is held just above the Horn of Africa. Like, the entire bottom part of Africa holds China and Japan. The UK fits into almost completely fits into Madagascar, and yet there's only one movie about Madagascar, and that's not probably that accurate. So I mean, it's really disproportionate for the size of this continent. We really don't pay enough attention to it, and that's part of the problem why we sort of ignore Africa as a continent, and that we think it's one country rather than a whole slew of countries that are all relatively big in size. So here's my in-class activity. You don't have to post anything right now for this, but I wanted you to try this out. Try the truesize.com. Have a look at it. I think it's fascinating. I'm going to close the door so we don't get quite as much distortion from my wife talking on her phone. Try the truesize.com and see where Canada fits in. I did Canada myself. I found it fascinating seeing how Canada, compares in size to Saudi Arabia, for example. Uh, it's a useful little exercise. So give that a try. Pause the video, give that a try, and I'll come back in a second. And we're back. Okay. So, yeah, we could show you all of this, but I'm assuming most of you tried that. So, also the one other wonderful thing about maps, because we're projecting it onto 2D, every single way you consider like going from point A to point B is always wrong as well. Because I flatten the map, but the actual plane goes in the air. The path along a sphere is actually different than what you would expect for the path on a flat surface. And so I don't know if many of you have traveled between different continents, but it gets really fun. Like going from Toronto to Paris, you go over essentially over the North Pole, right? You just take this huge leap up and over. You don't go straight line across. You go up north and then go down south again, just because the map the map distorts the fact that the fastest path is actually to go north and then going back down. Okay, and if you want to have a quick look at all of these Cantor maps, blocks, there we go, I actually have them already up. So we can look at all the various ways these maps actually distort over time. So here's Mercator. Notice what Mercator is the thing that stands out of all of this is parallel coordinates at their best, right? Which is the weird one out of all these maps? Which is the weird one? Whatever this one is. Oh, Mercator. Why? Because in terms of angular distortion, it is easily the best of the best. But in terms of area distortion, it is easily the worst of the worst, right? By conserving the angular relationships, by making it, if I go straight east, I go to this country, right? A Mercator map tells me which direction to go in if I'm traveling on a boat, but it horrendously disturbs the area or distorts the area, especially around the poles. So Antarctica looks like it takes up half the Earth. It doesn't. So, and then other scales here. Here's one that's slightly. Oh, let's do the next worst for angular, right? Pretty bad for angular, and hopefully get another one, right? Ones with zero angular distortion, actually, or zero area distortion, almost invariably they're mutually exclusive. If I have area distortion, I don't have angular distortion, and vice versa. And depending on what kind of projection I have, it depends on what I need. So let's have a quick look at. Here is a bunch of map projections over time. It'll actually transition. I find it fascinating. So, and we'll just wait for a couple transitions. It's not perfect because how it distorts, but notice that the flow itself of all the countries, how they're moving around, actually tells you where the distortion is. It gives you the movement itself tells you how the distortion works. It's how a fisheye lens also works. Movement, how the things distort over time versus what you expect tells you what the projection is actually doing, and therefore lets you infer how good or what kind of problems a particular projection, what kind of problems a particular projection gives you. All right. And of course, I don't know if this is actually true. According to this, it's what Australian schools show, but that may not actually be accurate. I didn't confirm. But yeah, why is everything the other way around and always centered around North America? Well, because the person making the map is living in America, most likely, right? This is why it's useful to think about things from a different perspective, including upside down. So, the big thing for me, or the big thing for you guys when you're making a map, is you have the real world, you have some cartographer's interpretation of the world for a world map at least, or for just an area map if you have an area map. So how you interpret that real world, what things you put down, then how you project it, and then you make this map, and ultimately it's the viewer or the reader of the map, how they interpret the world. But there's a number level of distortion here. The real world is distorted by the cartographer, and the reader itself is distorting the world because they're interpreting it via the map, which then is interpreting the real world. So this is a case of broken telephone. And if you're not very acutely aware of how these distortions actually occur, you're going to get people thinking things through the wrong way. You'll get people thinking that Canada is 4 times the size of the United States, or that Africa is a small little country, which is actually a continent and a bunch of countries, and they're all big, right? It changes how you view the world because the real world is different than what the map is, which then infers how you interpret the real world. So we have three different types of maps, just to let you know. So we have a reference map. That is a generic map. This is, I don't know what people are going to use this for. Give them a map. We have thematic maps. This would be things like, here is the precipitation in the entire area, right? It's for a particular theme, but not a particular task. You might use it for a particular task, but the task is not very pinpointed. And then there's special purpose maps. Things like, well, actually, I'll show you an example of it. So, it has several, this types of several spatial data without, this does not have a specific emphasis on one thing. This is thematic displays, like precipitation, like land cover, like the amount of, I don't know, different minerals and whatever the case is, right? Different kind of vegetation, right? It's not necessarily, but if I'm looking for spruce trees, I want a different map than a thematic map. A thematic map might be all vegetation or all different types of vegetation. Is it a boreal forest, whatever or is it tundra? And then a thematic map is for a particular task. And here's an example. So here's my reference map. Here's the vegetation. And here is in Thailand. And here is the Thai railroad system, right? I'm trying to get from point A to point B, and I need to get there. A map of Boston or a map of Ottawa. So I have a map of Ottawa. The thematic map might be the amount of snowfall or the kind of precipitation in Ottawa. And the special purpose map might be the OC Transpo map, right? Or knowing how to get to some other part of Ottawa or where the particular festivals are, right? The festival group, for example. I gotta get your short names down for this for your group names. The festival group has a case of you have a map, and what's the point? It has a very specific purpose. It's for helping people find a particular events. You don't care what anything else is. You need contextual information to help people find their way, but you're trying to minimize that. You're just trying to provide the main key piece of information. If you're talking about maps of Toronto and how dangerous are certain areas, I don't care where I might want to care where the Eaton Center is. It's a landmark, or the CN Tower for that matter. But I don't really need all the detail about all the various streets, or where all the various where there's other stores or things like that. I have a particular emphasis. It's a particular tool. Now, you could make it up to a thematic map if you don't know how they're going to use the tool, or a special purpose map if you have a very specific thing that they're trying to do with your tool. But pretty much none of you are going to be using a reference map. It doesn't make sense in your case. And, so I wanted to point this out. I just clicked it off again. I want you to think about tourist maps. I was meaning for it to do an animated transition. I didn't set that up. So I want to take a moment to think about something. You don't have to write it down. Actually, what we'll do is I'll open up the Google Drive for this one as well, for this particular exercise. I want you to jot down all your thoughts on what makes a great tourist map. Go ahead, look up a tourist map if you want. Tourist map would be like if I get a map of Ottawa from a tourist district, or if I'm getting a map of Paris if I'm visiting France, or if I get even a map of Disney World. There is something about those kinds of maps that are special from every other map, from a reference map, from a train map. If they're actually a kind of special purpose map in reality. Or it's not even a theme map or a thematic map, although it can start bordering that area too. What is special about a tourist map? And what are the key features of a tourist map? So I'm going to open the Google Drive. I want you to try, write something down, submit it, then then start the slides, start the video again. So if I see the same answers for the video as I see in your answers, that suggests that you just kept on watching the video and didn't actually do this exercise. So please stop the video. Think about for a tourist map. If I have a map, like a paper pamphlet map saying what to do in downtown Ottawa, for example, what are the key features that map needs to have? Okay, so I'm hoping you pause it. If you didn't pause it now. And a bit more of a break. All right, just because I didn't have the animated transitions, here we go. Here's at least my thoughts on this, and I think this is a well-studied particular phenomenon in other areas, but it's useful to think about for when you're making a visualization. Because if I'm trying to find a cheese festival, or if I'm trying to find a house to live, it has you have to be consciously and painfully aware of what I need to remove and what I need to keep. I cannot show, or I do not want to show, everything. I need to absolutely streamline what I'm showing. And so let's have a quick look at the Paris map, for example. It shows there, if you didn't know, there's actually a highway all the way around Paris. It's a very European thing to have, although Boston has something like that as well. But it has a highway that that circumvents the city, so you don't have to go into the city. That is a landmark that every single tourist will need to know. You also need to know where the tourist destinations are, the key ones. The Eiffel Tower, the Arc de Triomphe. What other ones do we have in here? I'm assuming the Moulin Rouge, Sacré Coeur. Sorry if I'm bastardizing the catacombs. My French accent's not working very well today. Right, all of these are landmarks that every tourist sort of, or most tourists, want to go. Here's Notre Dame. Um, where's the Louvre right here, right? I want to know where it is, and the key um, sort of point of reference, the river. It cuts through everything. You know where you are relative to the river, and you know what where the destination is. I need to know where the river is to find the Eiffel Tower. That makes my life a lot easier. Arc de Triomphe. I need to know it's on the north side of the river. I might also need to know the particular quarters, and so I can overlay. This would be a transparent overlay on top of things. I might overlay the different quarters if I want to go to the Latin Quarter and see things over there. Not a particular building, but go to the Latin Quarter. Greenwich Village, for example, in New York. Right? Some people just want to go there, not to a particular place. I want the landmarks. I want context. I want some key considerations, especially if I'm zoomed in. It might be like food, washrooms, where the subway is, the river. Um, right? I want to remove any amount of clutter. The roads are there. They sort of help a little bit, but I actually do not want to see the road names. I don't want to see, you know, if there's a sidewalk or anything like that. I don't want the details at all. I don't want to see where the buildings are. I'm trying to remove everything but the destination that I'm going to. I need approximate locations, and I need some information of how do I get there. Maybe some contextual information so I know I'm near a particular place. I might want to show Beth's paths, which we'll see in the Disney map, and I just want to be sort of. It has to be so shockingly direct that somebody that's running around looking after kids with one eye, one hoping they don't get hit by a car, and has a crappy piece of paper in their hand can still find where they're looking for. It has to be so painfully obvious that you stripped out everything else and they can still find their way. That's what a great tourist map is. So here's Disney. Now, I wouldn't say it's always perfect. That ends up being more in the thematic map. It is a geographic area. I have approximately where I'm going to go for everything, but it is not these four places. Every place is useful to go to at Disney, but I still have key points of view. So right here would be the castle. Right here would be the center square where everyone goes for the fireworks to look at fireworks during the castle. Here is Big Thunder Mountain. Here is Space Mountain down here. Here Fantasyland's over here. Right? I've listed off the individual key areas. I have different colors for those areas. I have key walking paths to get to particular areas. And it's clear where the walking path is to get from one place to another, so I don't get, I get here and I go, how do I get to Tomorrowland? I make a beeline here. Where is this one particular place? Oh, I consult the guide over here and then look. What I can, and those are actually organized in a different way. But what I don't do is put every single ride, every single thing in full text on this map. I can't emphasize everything, because if I ever emphasize everything, I emphasize nothing. And that's so I want to know where the river is for. This would be for, there's a little island, Tom Sawyer Island right here, which is quite nice. Um, I'm just trying to streamline things to help people understand where they're going when they're running around after crazy kids. Okay. So What have we talked about for maps? Well, we've talked about geographic maps, just that's a straight geographic map up there. We can even do street maps. Those don't have the same distortion effects because they're at a closer zoom, and I need to know where the streets are, maybe the directionality of the streets. I might need street names on this thing. I have flow maps. This is me overlaying information on top of the map, so I can put glyphs on it. I can actually show lines indicating one place to another. Statistical maps would be another kind of overlay where I have a chloropleth map. I color in the area. I can overlay colors on top of the area with a bit of transparency underneath, or I can put dots or icons or whatever the case is, indicating some statistical measure, like dot color, dot size, dot transparency. Heck, I can even do extreme distortion maps. This is all of North America. Well, the North American, the triplet group for North America. It depends on if you want to consider Central America as North America. So Canada, the United States, and Mexico. Notice it's based off of the population. Right, Mexico is way bigger than Canada in terms of population. But notice I'm still keeping the height, the y coordinate, to actually indicate what country I'm looking at to make it more obvious. But most of it, I got rid of most of the other shape of the countries just so I can indicate the data more clearly. So think about this for a second. What about a Google map? Here is, I didn't update it for you guys, sorry, but here is the Back Bay. Here is around Northeastern University. So Massachusetts Avenue is right here. Northeastern's right here. This is actually where my old office was right here. Right here is the Greenbelt. Here's Fenway. Fenway Park is right here. The cathedral. Yeah, that's where the Sox play. Anyways, here's Ruggles, one of the major train stations. What does this actually show at this height? What are they trying to indicate? What are the key landmarks? What are they trying to help make sure people know? Now, if you zoom into a Google map, what do you see? If I zoom out, what do you see? What's the level of granularity that I keep on getting at every level? And notice what they sort of mercilessly remove at every single time, every single zoom in level. Okay. We also have wind maps in case you're wondering. I love these sorts of things, and you can have a look at the particular gallery. You can actually indicate weather information for the entire country just by having some kind of animated overlay on top of your original map. We can show network. So this is flight paths in the United States. We could be talking about computer networks as well. We can show any number of things. We can put a network diagram, a node lake diagram on top of the actual world map and to give sort of context to things. And this is something I also wanted to have you could have a look at. I know you're not Bostonians, but I don't have an equivalent for this for Ottawa. So I'd like you to have a look at worldmap.harvard.edu/Boston. We might be able to get other cities. I didn't check for other cities yet. I assumed it did not have Ottawa. But you can check any city you want. But have a look at this, and maybe not looking at building age, for example. We have, by the way, contextual information. We have what subway lines are going through this. But why not look at ethnography, for example, or not ethnography, demographics. Why don't we look at look at cultural demographics and socioeconomic status, for example. Have a look at those combinations of things and see what if you find any particular patterns. Boston, despite seeming like a very nice city and seeming like everything's running hunky-dory and everyone's likes each other, there are some major concerns and major problems in the greater Boston area in terms of how people cluster together and separate from each other. It's not a very integrated city. And having a look at that, it might be a very eye-opening experience for many of you. It's a useful or interesting look at a map and notice what they get rid of. They get rid of everything but the major data that you're trying to look at. They give you context and that particular task you're trying to do. That's what a great map does. All right. So our take-home lesson for right now is that although maps are intuitive, not only can they can lead to distortions, like a chloropleth map which is when you color a particular region based off of piece of data, one data point. That leads to distortion because a big giant red area might seem like it's more impactful than a small little red area, despite the fact the population in a giant area might be smaller than the small area. New York City versus Montana. Right? The actual size of the area being colored in, that's based on geography, but it may not be based off of the size of the population. So Orleans is much bigger geographically, but much smaller population than anywhere in the center of the city. You cannot assume that it's easy to build a map, or it seems intuitive, so people just sort of underestimate how difficult it is. But you really have to really think through your designs and then test it. And that's why we're doing that usability test later. And for me, at least, you have to mercilessly cut down clutter. Get rid of anything that's not directly impacting your visualization. Get rid of anything that you don't think is part of helping you with the context, helping you ground your work, or the data that you're trying to show. If it involves street names that you don't need to show, get rid of them, because they're not there. Any clutter means that you don't get as much impact from your data. So I think with that, we're going to storytelling next. I'm going to pause the video for right now and let you have a break, and we'll come back in a second. Thanks.